Hello class, today we're going to look at section 3.6, function notation and linear functions. Two main concepts going on, or objectives, is using function notation, which is the f of x notation, and graphing linear and constant functions. And we're going to look at the domain of those as well. Okay, so let's talk a little bit about what function notation is, or see what it means. So in the first one we have y equals 2x plus 8. So this is just dealing with y equals. Well, we know if x is 3, then we plug in 3 and that should generate the y value. So we get y equals 2 times 3 plus 8. And then we go ahead and multiply, and that gives us 6 plus 8, or y equals 14. So we have when x is 3, y equals 14. The notation we're going to look at in this section is function notation. So notice that the y has been replaced with f of x. So we have y is replacing with f of x. Everything else is the same for the equation. So this is just saying now we have a function, f of x. That's the same, we just have y equals. So when it's in function notation, you've already verified that it's a function, so you can assume all the properties. This notation of f of 3 is the same as saying x equals 3. Notice that the x and the 3 have just been replaced. So we're going to do the exact same process we did over here. We're taking 3 and plugging it in for x. Now the way it's going to look is we're going to still have the f of, and instead of x, we've plugged in 3. So f of 3 equals 2 times 3 plus 8. Now this notation over here on the right, the function notation, is just telling us that we plugged in 3. So as we go through this f of 3 stays. This doesn't mean f times 3. So this is f of 3. And that equals 2 times 3 is 6 plus 8. And we have f of 3 equals 14. We get the same answer. Now the difference is, if you look at this final answer, we don't know what number was plugged in. We just know the result is 14. We go back up here at the top and go, oh yeah, we plugged in a 3. With this notation here, this is saying, it's telling us that we originally plugged in 3 and the result is 14. Okay, so make sure that this is just a notation telling us what we plugged in, not f times 3. Okay, so let's look at a few more of these. Again, you're welcome to pause or rewind if I'm moving too quick. So we have, let f of x equals negative 3x plus 4, and g of x equals negative x squared plus 4x plus 1. Find the following. Okay, so we have two functions up top, f of x and g of x. So what we want to be careful with is the notation that's given. So if you look at this first one, we're dealing with g of x. So we're dealing with the g function. So we want to take negative 2 and plug it into the g function. So it should be g of negative 2 equals negative x squared. Well, my x is negative 2 plus 4 times my x value, which is, again, negative 2. So notice everywhere there's an x, I'm plugging in a negative 2. And we have a plus 1. Okay. So we've taken the value of negative 2 and we've plugged it in for the x term. Now all we have to do is simplify. again, remember this left side is going to say g of negative 2. Here's a common mistake. We want to simplify these two negatives to become a positive, but remember exponent comes first. So I have to go ahead and square a negative 2, which becomes a positive 4. Notice the negative sign is still out front. Here we have negative 8 plus 1. So that gives me g of negative 2 equals negative 4 minus 8 is negative 12, plus 1 is negative 11. Okay. So when we plug in a negative 2, it will produce a negative 11. Alright, let's look at another one. So this time we have f of x plus 2. So that tells me I am using the f function. So we have our f of x function up here. And we're going to take x plus 2, we're going to plug it in for x. So this is what it will look like. So f of x plus 2 equals negative 3. Instead of times x, we're taking that whole x plus 2 and we're plugging it in for x. So I'm going to have negative 3 times x plus 2. Notice that I used parentheses, so remember to distribute. And we have the plus 4 in back. Okay. So we've taken the x plus 2 and we've plugged it in for x. Okay. And we keep simplifying. So f of x plus 2 stays the same. Distribute the negative 3 in. That gives me negative 3x minus 6. And then we still have the plus 4. Combine like terms, and we have our answer. So f of x plus 2 equals the negative 3x stays, and then negative 6 plus 4 is negative 2. So you're able to plug in a number, you're able to plug in variables, you're able to plug in an expression like x plus 2. Whatever's in that parentheses behind the f is getting plugged into the original problem. Okay. Let's go ahead and look at one more. Okay. So on this one, notice we have two things we're working with. We are going to work with f of 4, which means I'm taking 4, plugging it into my function f. And then we're also working with g of 4, which means we are plugging in 4 into our g function. Notice the subtraction. So we want to subtract the whole result. Okay. So what this is equal to is we're going to take 4, plug it into x. So we have negative 3 times 4 plus 4 minus, now what I want is to subtract that entire part, so make sure you use parentheses. And we have negative x squared. We're plugging in a 4. So let's plug in a 4 there. Plus 4 times x, and again x is 4, so let's plug in a 4 there. And then we have a plus 1. And we're going to close the parentheses. So we have a subtraction here, so we need to distribute that through. I would probably go ahead and simplify all of this down first, and then worry about that. Okay. So up front, we have negative 3 times 4 is negative 12, plus 4, minus 4 squared is 16, with the negative in front, gives me a negative 16. 4 times 4 is 16, and then we have a plus 1. Negative 12 plus 4 gives me negative 8 minus negative 16 plus 16 gives me 0, so I just have a 1 in there. Negative 8 minus 1 gives me negative 9. So this is f of 4 minus g of 4. You're not going to always see the same number for both of them. So if you see a 4 and a 7 here, just make sure you plug in the 4 into the g and the 7 in, or sorry, the 4 into the f and the 7 into the g. So that's a little bit of function notation. Let's look at another way of using function notation. With this one, we have a table of values, and we're asked to find f of 2 and f of negative 1. So let's go ahead and do A. F of 2. That means when I plug in 2 for x, what is going to be the result? So when I plug in 2 for x, what is it going to produce? It's going to produce a 4. So f of 2 equals 4. We're going to want to know what happens when I plug in 2 for x. Well, there's x is 2. The result is 4. Part B. F of negative 1. Well, this is saying if my x value is negative 1, which is right here, what is it going to produce? It's going to produce a 1. So f of negative 1 equals 1. So this has done the work for you. The table of values is already filled out. All the x values have been plugged into the function, and it produces the y value for us in the table. So all we have to do is match up the notation. Okay, so this one has a little bit of extra work. Again, if I'm moving too fast, you can always pause, rewind, do whatever you need to do to keep up. Okay. So number 41, it says an equation that defines y as a function of f of x is given. Solve for y in terms of x and replace y with the function notation f of x. So basically what we're doing here is we're going to solve for y like we do with when we're graphing. Put it into y equals mx plus b. Then after we do that, we're going to take y and just replace it with f of x. So part A. So if we're trying to get y by itself, let's move over the 4x. So we're going to subtract over the 4x. And that gives me negative 3y equals negative 4x plus 8. And then divide by negative 3. And we have y equals 4/3 x minus 8/3. Okay. So we've solved for y. The second part now is replace y with the function notation f of x. So I'm going to take y and just make it f of x, because this is a function, it's a linear equation. And we have 4/3 x minus 8/3. So that's part A, is solve for y and then change y with f of x. Part B is, now that we have our function, find f of 3. Remember, f of 3 means we're plugging in 3 into our function. So I have 4/3 times 3 minus 8/3. So we've taken the 3 and we've plugged it into our problem. From here you have some options. What we're going to eventually have to do is we're going to have to subtract these two fractions. Remember, when you subtract, you want common denominators. So yes, I could reduce this away, but when I reduce that, I'm going to be left with a number that's no longer a fraction with a common denominator. So what I'm going to do for this problem, make my life a little easier, is I'm going to multiply straight across to give me 12/3 minus 8/3. So I know this can reduce, but since I already want common denominators, I'm not going to reduce it. We'll go ahead and subtract. So 12 minus 8 gives me 4, and I keep the thirds. If you reduce that to a 4 there, then we have to go through the process of finding the common denominator and making them common denominators again before we can actually subtract. So that's why I decided not to reduce with that problem. Yeah. Okay, so let's look at graphing a linear function and then giving the domain and range. So when we graph our linear function, we would like it in y equals mx plus b, which we have. Remember, our f of x is the same as y. So this tells me that my b value, remember, is my y-intercept. That's going to tell me to start up 5 on my y-axis. My slope is going to tell me how to get to the next point. So we have m equals -2. Remember, I can always make that a fraction by putting it over 1. So -2/1 means down 2, right 1 from my blue dot. So the slope tells me how to get from my first dot to my second dot. Okay, connect the dots. Hopefully your line's a little straighter than mine. That one's pretty bad. So that's the graph of our linear function. Now we want to give the domain and range. So the domain. We talked about yesterday working with equations in the form y equals mx plus b. When the domain, we're talking about how far left and comma how far right our x values go. Well, if you look at this, this is working left forever. Yes, it looks like it's going up, which it is, but it's also working left forever. And if you notice, the bottom is working down, but also right forever. So your domain for this is -infinity to +infinity. And it's working left and right forever. Our range is how far down my graph goes and how far up my graph goes. So down, my graph is working its way down forever, and that's -infinity. The graph is also working its way up forever, and that's +infinity. So the domain is all real numbers, or -infinity to +infinity, and the range is also all real numbers, or -infinity to +infinity. Let's go ahead and look at another one of these. So go ahead and pause, see if you can get this graphed, and then find the domain and range. Once you're done with it, go ahead and unpause me and see if you were correct. welcome back. Hopefully you've taken a moment to pause and attempt the problem. So the first thing we're going to do is graph this one. Remember, this is the same as y equals -4. We're missing our x term. So this tells us that we have a horizontal line. So 1, 2, 3, -4. And this is going to be a horizontal line at -4. So that's the graph y equals -4, or g of x equals -4. The domain. Again, this is how far left my graph goes and how far right my graph goes. So left is -infinity. Notice it's going left forever. Right is positive infinity. Notice that it's going right and left forever. So my domain is -infinity to positive infinity. Now my range is how far down my graph goes and how far up. Okay, so the lowest point on my graph is at -4. The highest point on my graph is at -4. So notice that range, remember, is your y values. So any y value or any point we pick on our graph is going to only have y values of 4. So I end up not having a region for this one. I just have one value for my range, and that one value for my range is a 4. So the range is just 4 for this one. And notice that it should be -4, sorry, since we're down 4. Okay. So this is down 4, -4. Let's look at a few word problems, and there's multiple parts to these. So as you go through, you want to go back to the original problem, check to see where you're at. Okay. So we have, to print t-shirts, there is a $100 setup fee. Well, $100 setup fee, that's your initial price. That's a one-time fee. So I have plus 100 as my setup fee. Now it says there is a $12 charge per shirt. So that per is telling you that this is your slope. And it says let x represent the number of shirts. So this is 12 per x, or 12 times x. And number of sheets are printed, and f of x represents the total. So the total for this is our function f of x. So we have a $100 startup fee plus $12 per shirt. And we have our linear function that models this. Now the next part is, now that we have our function, let's go ahead and start finding some values. So this is asking us to find f of 125. So this means take 125 and plug it in for our f. So we have f of 125 equals 12 times 125 plus 100. So we've taken the function and we're plugging in 125 for x. Let's go ahead and calculate this out. So we have 12 times 125 equals 1500. So f of 125 equals 1500 plus 100. Now f of 125 equals 1600. So we've taken the value and we've plugged it in. And now we're asked to interpret our answer. So let's think a little bit about what we found. We determined that x is the number of t-shirts. Okay. And the f of x is the total. So this is saying the cost for 125 shirts is $1,600. So we've determined that for 125 shirts it would cost $1,600. Let's look at another one. Part C. So it says find the value of x. So now we're looking for x, and we have the f of x equals 100. So notice the difference in our notation. So let's go ahead and write our original function, which was the 12x plus 100. So the notation up here, notice the 125 is inside the parentheses. It's replaced x. So we're taking 125, plugging it into the function. This one, we have f of x equals 1,000. So this is replacing f of x with 1,000. So it equals 12x plus 100. So notice that I'm not plugging it in for x. I'm plugging it in for the total, or the f of x. It replaces that whole f of x. So we go ahead and solve. So subtract 100. And we have 900 equals 12x. And then we go ahead and divide by 12. And we have x equals 75. So the number of shirts that we have is 75. The total that it's going to be is 1,000. So this would be if you had a budget. You were given a project to get some t-shirts. You only had $1,000 to spend. Figure out how many shirts you're going to get and go from there. So we have the cost for 75 shirts is $1,000. So you can see how you can use this function in both ways. If you have the total amount of money, you can figure out how many shirts you can get. If you know how many shirts you want, you can figure out the price. Let's look at one more word problem, and then that will be it for 3.6. So this is number 63. It's used in the table of values a little more. Again, so if you need some time to copy this down, go ahead and pause, and then we'll get started. Okay, welcome back. So we have that the table represents a linear function, and we have some parts to find. So what is f of 2? So again, f of 2 is stating when I plug in 2 into my function for the x value, what is it going to produce? It's going to produce 1.1. So we don't actually have the function to plug it into, but we do know the results of each of these. Somebody has done the work for us. Now this one is asking us if f of x equals negative 2.5, what is the x value? So I'm trying to find the x value if the result was negative 2.5. So let's go at our table and let's scroll down until we find negative 2.5. There's negative 2.5. We got the negative 2.5 by plugging in an x value of 5. So x would equal 5. So you can either know what the result was and figure out what the original value was plugged in, or if you knew what original value was plugged in, then you should be able to find the result. What is the slope of the line? Well, we've worked in this chapter with the slope formula. So the slope formula is y2 minus y1 divided by x2 minus x1. So what I'm going to do is I'm just going to use two of my points. Here's my x1 value, y1 value, x2 value, y2 value. Remember, f of x and y are the same. So y2 is 2.3 minus y1, which is 3.5, divided by x2 minus x1. So that gives me negative 1.2 divided by 1, which gives me negative 1.2 as our slope. So anytime you have a table of values and it's told that it is linear, then you can use the slope formula. Part D is asking us to find the y-intercept. Remember, the y-intercept is at the point 0, b. So if I have an ordered pair where the x value is 0, then my b value is my y-intercept. So notice that that first point we have 0, 3.5. So we have 0, 3.5. That means this is our b value. So when I write my equation in y equals mx plus b, my m value is what we found in the previous problem. My b value is what we found by looking at that first ordered pair, because that's when x was 0. So we can go ahead and say the y-intercept is at the point 0, 3.5. Okay. So the last part, part E, is saying, well, now that you have the slope in part C, and now that we have the y-intercept in D, write the equation. So I sort of started that process already up here. So I'm going to go ahead and continue that by plugging in the m value, which is negative 1.2 times x, plus our b value, which we found was 3.5. So this is in y equals mx plus b. If we want to write it in function notation, which is the last part of this, we're going to take the f of x and replace it for y. So we have equals negative 1.2x plus 3.5. So that should give us our equation in function notation. So we're taking all the parts, piecing it together, and coming up with the final equation. So that's A through E. Again, if I move too fast, go ahead and rewind me and go back to what you need help with. So that's 3.6. Hope this was helpful. If you have any questions, please let me know.